Hello, virtual GED students. Welcome to our new unit. I'm super excited. We are going to be talking about interpreting word problems. So if you haven't heard, the two biggest skills on the GED are algebra and interpreting word problems, and sometimes both at once. Okay, and so we are really going to be digging in deep with word problems and how do you know what to do. And we're going to start today by choosing the correct operation. Now, I highly recommend that anybody who's going to do this lesson goes back and make sure that you've watched a previous lesson in our Math Basics, our Math 101 course, known as the basic operations. And we have some GED students joining us today. We have Ashley, David, and Nicole. Welcome, you guys, to class. Let's go ahead and get started. So a couple of weeks ago, I think David was with me. We talked about the basic operations in math, and we talked about the 4 basic operations. David or anyone, can you refresh me about what the 4 basic operations are?
Addition, subtraction, multiplication, division.
Absolutely. Now, those certainly aren't the only operations that come up or even come up on the GED. There's more than that. But these are the 4 basics and are super important for interpreting word problems. Now, last time we talked about the symbols that we use for these, and we talked about some math terms, sum, difference, product, and quotient. But today I want to talk about these things not from the point of view mathematically, but from a really real world standpoint. Like, what do they mean? Because I'm sorry to say that a lot of GED students hate word problems. They get lost in them. They don't know what to do. They kind of just pick up their calculators, start mushing numbers together and praying, which, you know, it's just not a good problem solving technique. We need more than that to go on. So today I want to really talk about what these things mean. We said last time that addition was what? Do you remember, David, what it means to add numbers together? What are we doing when we add? Anybody can answer me.
You're increasing the value of a number.
I'm so super glad that you said that, so we can get that out of the way right away. To add does not necessarily mean to increase. So don't feel bad, David, because this is a common misconception that students have. But just an FYI, I can add and actually end up with less. For example, if I have $5 and then I add $4 of debt to my account, this is addition, and yet I would end up with less money than what I started with. My account would not increase necessarily. Now, I know why you feel like addition is increasing, because we're used to whole numbers, not negatives. We're used to positive numbers, and when we add positive numbers, they generally do increase. But this idea of increasing, not accurate enough for me. Anybody else want to give it a try? What are you doing when you add?
To combine.
I love that. Absolutely. Adding is combining. Now, this is super important. Any sized groups of the same kinds of things. I love what Ashley said. She said that we were combining groups. And I just want to clarify, because both addition and multiplication can be seen as combining groups. You know, like your elementary school teacher told you when Johnny has 3 candies and Timmy has 2 candies, how many candies do they have all together? And we knew that we could add Jimmy and Johnny's candies, any sized groups. But you know, things would change when everybody has the same number of candies, right? We can still combine groups, but there's like a shortcut, faster way to combine groups, right? I can say, if every student in the class has 5 candies and there's 10 students in the class, you know, I'd still be combining groups in that case, but in that case, I'd be combining same-sized groups. So let's come down here to multiplication and write combining same-sized groups. Okay, but now coming up to addition again, we said it was combining any size groups of the same kinds of things. I cannot point out how important this is. So I'm going to do a little bit of scratch work over here in the subtraction box. Don't you guys stress it, because you don't have to write this down necessarily. I just don't have enough room in my addition box, but I just want to have some conversations with you guys about this. Okay, I have an interesting problem. I'm curious what 5 apples plus 4 oranges is. And I'm not even joking. I really want to know. So I've got 5 apples in one hand. I've got 4 oranges in the other hand. I put them together. What do I have?
9 fruit.
Oh, I heard 9 fruit. I would totally accept this answer. Now, I think something is really interesting. You said 9 fruit. How come you didn't say 9 apple oranges?
There's no such thing.
There's no such thing, says David. Okay. You laugh at me. I'm sorry. You guys, you laugh at me like Kate is making really silly points, but let me just show you what I mean. So you say this is 9 fruit. So we have apples and we have oranges. By putting them together, we don't suddenly end up with a new thing. We're not going to suddenly have apple oranges, of course. And so some students, when I ask them what's 5 apples plus 4 oranges, they tell me, well, Kate, it's just 5 apples and 4 oranges. And I agree, 5 apples and 4 oranges is just 5 apples and 4 oranges, whether they're in separate bowls or together in the same bowl. And yet, some students will tell me 9 fruit. All of a sudden, Nicole was able to add. But what did Nicole have to do in order to add those apples and those oranges?
Make a basket of fruit.
Exactly. Yeah, she had to give them the same name. They had to be the same kind of thing. As soon as you called them both fruit, they were the same kind of thing, and we were able to add. Now, you guys tell me, yes, Kate, that makes total sense. I think that's brilliant, and you say brilliant things. And then yet, when we get to other branches of math, you guys do really weird things with addition. And I'm like, hello, I thought that we understood that we could only add the same kinds of things. So let's go ahead and look at what I mean. So here's an interesting thing that students do for me when you're in the basics of math and you're adding decimals, where we really need to understand that adding is combining any size group of the same kind of thing. So let's look. Here's a dumb question. So which one of these is lined up properly so that I can add 235 and 3? Yeah, the third one. So I've never met a student yet who didn't know it was the third one, but can anybody tell me why? Why is that the way we line up?
Because of the ones, tens, hundreds place.
Exactly. Who said that? That was brilliant.
Nicole.
Nicole, I can only add ones with ones. 5 ones and 3 ones will give me 8 ones. And let's make this a longer number, like say it was 43. I could only add 3 tens and 4 tens, tens and tens. And my answer, 7, would be some number of tens. I'd have 7 tens. And so that's why the addition algorithm works the way it does, is because adding is combining any size groups of the same kinds of things. Okay, so you guys say it makes sense, and yet you make a lot of mistakes when I ask you to add decimals. I cannot tell you how many students do this, and I'm going to do it in red because it's such a common student error. I ask them, what's 25 plus 0.25? And they come over here in their nice little side work, and they do this, and they tell me 50 cents. And it makes me laugh every time. I'm like, how in the world is $25 plus 25 cents suddenly 50 cents? I'm super glad life doesn't work this way. But can you tell me what that student did wrong, you guys?
He didn't place the 20.25 in the right area.
Yeah, why not? Where should he have placed the 0.25?
Because $25 is 25.00.
Sure. $25.00. Is that what you're trying to tell me?
Yeah, so if you're going to add 50 cents to that, you got to put the 0.25 where the other zeros are.
Sure, I could totally do it that way. Not the only way I could write this, but why does this work? Why does this work? What's good about David's math?
Your decimals are lined up. So you
Yeah,
bring
it's
that
not
down.
the decimals, because I don't add the decimals. I know that a lot of teachers tell you, make sure you line up at the decimals. And it's just a quick way of saying that all my place values line up. That's the important part, the place values. If my decimals are in line, all my place values will be in line, so that my ones are going to add with my ones, my tenths with my tenths, my hundredths with my hundredths, and so on and so forth. We can only add the same kinds of things. Okay, so once again, I say, you tell me that you're clear with that. You say you are, and then yet we get to fractions and you guys do really crazy things.
But I don't know about me.
I'm not talking about you personally, David, just students in general. Okay, so I'll ask GED students to add 1/5 and 2/3. Think again, like 1 apple and 2 oranges. And you guys make apple oranges. I get it all the time. Students will tell me 3/8. And I'm like, how did you add fifths and thirds and suddenly get eighths? It doesn't make sense. Just like adding apples and oranges wouldn't give you some weird super fruit known as apple oranges. You might be wondering, how would I do this problem? Well, just like you did with the fruit earlier, you would have to make them into the same kinds of things before you added them, which is a lesson for another day. But still, I just wanted to point out that if you understood this about addition, you would not mess this problem up. So now one more thing though, students will be good with fractions, they'll be good with decimals, good with word problems, and then as soon as we get to algebra, they'll lose their minds. So students do all kinds of weird things here. I'm looking at 2x plus 3 X. Well, if I had 2 apples and 3 apples, I would get what?
5 apples.
Exactly. So guess what? If I have 2x and 3x, I'm going to end up with
5x.
5x. And yet students give me weird, crazy, nuts answers like 5x squared. And I'm like, where'd you get apple squareds? Just from putting them in the same bowl, they became, no, that doesn't make sense. So wonderful. Now I made you do this last time, but I'll make you do it again because it's so super important. We need to understand that every operation in math has an inverse, Anybody know what that word inverse means?
Opposite.
It is the opposite. Brilliant. So every operation has an opposite. If we can do it, we can undo it. Now I kind of want to take that back, that every operation has an inverse. Everyone, we're going to see on the GED, okay? But if we can do it, we can undo it. So if we can put things, put any size groups together, there must be a way to take a group out. And of course, we're talking about subtraction. Subtraction here is removing a group from a total. This time, instead of making a total, we're starting with a total. Instead of putting together groups, we are taking out a group. Now, notice though, because addition and subtraction are inverses, it is going to have that same idea that it has to be the same kinds of things. You cannot suddenly reach into a bowl of apples and remove oranges. It's not going to work. Multiplication. We said one way to think about multiplication is like repeated addition or combining same-sized groups. It's like the shortcut way. I love that students understand this a lot. I'm not going to spend a lot of time on here. We did in our last video. But I did also want to point out that multiplication is an act of scaling. So when you scale something, that means increasing or decreasing in size. Why am I making you learn this again when we just did this before? Because we're going to be looking today at the context of word problems. So if they're asking us to put together a bunch of same-sized groups, we'll know we're multiplying. Or if they ask us to scale something down or up in size, again, we'll know to multiply. So then multiplication also has an inverse. Of course, if I can put things together, then I can also, instead of combining same-sized groups to find a total, I can break them up, break a total into same-sized groups. That would be a picture of division. I'm good with this for now, and what we're going to do now is we're going to go look at a bunch of applications of this. It's kind of a rehash of what we did last time.
Is division also repeated subtraction?
It absolutely is. And I didn't mention it that today because I'm not going to use that aspect of it today, but it really is. Like, for example, if I said to you, I've got 30 candies and I'm going to split it equally, I'm going to give each of my students 5 candies. Well, then I'd remove 5. And then I'd remove another 5 and another 5 and another 5. And I'd see how many students that I could feed with that. You see what I'm saying? Removing 5 at a time. So it is like repeated subtraction. Good question. And by the way, is there anybody here who's ever struggled with long division? Yeah, that's a really big struggle for a lot of students. In fact, it's the only video that I've ever done that's gone viral. Math teachers don't go viral on YouTube, okay? But long division does because so many people struggle with it. Well, as it turns out, long division is not the only way to do division. There's lots of ways you could do division. Long division is just a tool. And there's another method that I use to teach students who have struggled with long division for a really long time, like you keep struggling and not getting it. It's known as partial quotient division, and it's based on the fact that division is just repeated subtraction. And it is wonderful. So I'm happy to share that with anybody if they've long struggled with long division, because it can be a much more intuitive way of dividing. The examples. So I have some very simple word problems today. I didn't make them complex because I want to be more focused on the skill here. So a lot of you guys are going to know if it's addition, subtraction, multiplication, or division just by looking at it because you've been doing math as long as you have. So these first few simple examples, no big deal, but I really want you to not only tell me what to do, but why to do it. What in the wording tells you what to do? So let's go ahead and take a look. Number 1 says, for each of the following scenarios, determine the most appropriate operation: addition, subtraction, multiplication, or division. And let's look at A. And right away, I'm being mean because I don't give you guys any numbers. So A, I have students seated in rows in my classroom. Each row has the same number of students. I'd like to find the total number of students in my class. Interesting. And I want to know what operation I should use.
Multiplication.
Well, oh, David says multiplication super easy. David, justify your opinion. What in this problem told you that I should multiply?
Because it's the same number of rows in each row.
I like that information. That idea of repetition. So let's look at that. Same number of students. Yeah, same-sized groups is a really big clue that I'm either looking at multiplication. Same-sized groups is a really big clue that I'm either looking at multiplication or division. Same-sized groups happen in both multiplication and division. So why did I choose multiplication and not division?
Because we're increasing the amount of students in each seat.
That's a good guess and a really common one for students, but just like I did with subtraction, I can actually multiply to make things smaller. For example, if I did 10 times 1/2, I'd be scaling down. I'd be just taking half of 10. It would get smaller. So the increasing thing happens in both multiplication and division, even though students don't expect it to. So not that exactly. Here's what I'm looking at. Notice that it says this. I'd like to find the total number of students. There are two ways to find a total. We can add any sized groups to find a total, or we can multiply, find same sized groups to get up to a total. Okay, so this idea where my total meets repetition, that's where I'm multiplying. Okay, so I'm going to go with two questions, okay? These two questions will always help me. The first question is, am I finding the total, or do I already have the total? Am I breaking down a total? Now, I shouldn't say they should always help me, but they very commonly help me. Okay, guys, so what are the two ways to find a total that we've talked about with our operations today?
Adding and multiplication.
Adding and multiplication. Then my other thing, I could be breaking down a total. What are my two ways to break down a total?
Subtraction and division.
Subtraction or division. Wonderful. And then that second question will be along the lines of what you said with the same sized groups. Is there repetition? If I have repetition or same sized groups, then that puts me in the land of multiply and divide. If not, I'm only going to be able to add and subtract. Okay, so let's take a look at B. I have a bunch of students in a classroom. I send a group out to start testing. I want to find the number left in the classroom. And everybody said, what would my operation be here?
I want to say subtraction.
Absolutely. You guys get all bored. Subtraction. Yeah, okay. So back up your opinion. Why do you say subtraction? What here tells you that this is subtraction?
I want to find the number left in the classroom. So
You liked that wording, finding the number left in the classroom?
Yeah.
Definitely that was a big clue that there was subtraction going on. Anybody else?
I want to say the word out.
Oh, that we sent them out of the classroom? Like a group was removed?
Yes, left.
Sure. And it was just one single solitary group removed, not a bunch of same-sized groups. So yeah, subtraction, not division. Nice.
But if it was a bunch, would it be division?
If I was taking all my students and breaking them into a bunch of same-sized groups, then yeah. Even if I sent them all out to different rooms, 5 out to that room, 5 out to that room, 5 out to that room, 5 out to that room,
Perfect.
I'm still looking at division here.
Okay.
You know, but in that case, I'd probably be asking you something a little different. And we have one like that coming up. So let's take a look. Well, next one, C, says, I have some students on the right side of the room and some on the left side. I want to find the total number of students in class.
Addition.
Addition, absolutely. What about this problem? What wording told you addition?
Or you're telling me that there are some students on the right and then there are some on the left, and you're telling me you want the total number of them, so addition.
Exactly. I'm finding a total and I have no idea what size the groups are. Then D, I have a bunch of students in a classroom. I ask them to form groups of the same size and I want to know how many groups I will have.
It's division.
This one is division. This one is division. How come it's division? Now, David, the tricky thing is this could be multiplication or division because of this. Groups of the same size? Well, that happens in multiplication or division. So what part of this told me it was division and not multiplication?
You're separating them.
There you go. I'm starting with the total and I'm breaking it up. If it was multiplication, I'd be starting with the groups and putting them together. Division is starting with the big total and then breaking it back into the groups. Okay, cool. Super simple. Let's look at some more challenging applications of this, though. So one of the harder things that the GED asks students to do, well, I don't think it's hard because I speak the language of algebra, but students often think it's hard because they are used to not speaking my language and doing problems other ways. So one of the things that is a challenge for students is what's known as writing algebraic expressions. So on the GED, you're going to have to write in the language of algebra. They'll either ask you to write algebraic expressions, equations, or inequalities. We're going to be graduating to that stage, but right now today, we should be able to start writing expressions. Let's take a look. Number 2 says, for each word problem below, determine the appropriate operation. Okay, just addition, subtraction, multiplication, or division. But then I say, write an expression that could be used to find the indicated information. And then we are going to simplify so that we know what our answer is as students think of it. So let's take a look at A. It says, Jesus pays $325.75 per month for his car. Okay, we know how much he pays every month for his car. And then they ask, how much does he pay in car payments over the course of a year?
So multiplication.
You say it's multiplication. I agree with you. Can you back it up? Why do you say multiplication, David?
So if you take 325.75 and multiply it by 12, it's going to give you 390 or 3,909, which is your answer.
I agree with you, but what in the problem told you it was a multiplication problem?
It says over the course of a year, so you're assuming it's all 12 months of the year. So
wonderful.
So
over the course of
the multiply.
Good. Over the course of a year, told David that he was going to pay this. And thank you guys for having patience with what may seem obvious to you, because this is not obvious to all students. He's going to pay that $325.75 12 times. A year has 12 months in it, and so he's going to end up paying that 12 times, and so he times it by 12. Okay, now we do have to point out that this is not the only way to write this problem. Okay, so is there anybody who thought of a different operation that they could use?
I use the times symbol.
Oh, you just wrote it a different way, like 325.75 times 12, like this?
Yeah.
Yeah, there's nothing wrong with that. You're not wrong. We're saying the exact same thing. Is just, it's more common to use proximities with parentheses in algebra just because they don't want you to mix up times with the letter X. Okay, but you're not wrong or anything. But did anybody use a totally different operation besides multiply? Can anybody think of another operation they could use to do this besides multiply?
Yeah, I guess you could do addition.
You could. Exactly, Ashley. I could use addition. It would be kind of the long, slow way. Because if I did it with addition, what would I have to write as my expression?
325.75 plus 325.75, 12 times.
Yeah, Ashley doesn't even want to say it. It's so gross. No wonder we have a shortcut for repeated addition. There you go. It's too high. Well, any mathematician worth their salt is lazy. We're always looking, efficiently lazy though. Okay, you guys, we're always looking for the shortest way to do things. So yeah, I wouldn't want to write 325.75 plus 325.75 plus. I wouldn't want to write that out 12 times either. And so it'd be easier to multiply. Okay, now David, now I will take your solution. And by the way, guys, you should know that anytime you're working word problems on the GED, you know what you're going to have?
A calculator.
A calculator, baby. It's only for the first 5 problems of the GED that you won't have a calculator, and they won't look like this. Okay? Okay. So I need you to be really careful and know the difference between the expression and the solution, because on the GED, they could ask you for either. Okay, then let's look at, I don't know what that is. Kalena? Okay, Kalena bought 2.5 pounds of apples, 3/4 pounds of grapes, 1 1/4 pound of oranges, and 3 3/8 pound of bananas. Yeah, this is just so true to my own life. You should see me buy fruit, guys. I have 6 teenagers. So how many pounds of fruit did she purchase? Now, first thing I want from you, stop panicking about the fractions and just tell me, what operation is this?
Addition.
Absolutely. What told you that I would add here?
How many pounds?
Yeah, I don't know. I think I could use the phrase how many pounds in any number of things.
I think because they're different kinds.
Okay, so I have all these different kinds of fruits, and what am I doing with them?
You're adding
all of the pounds.
I'm putting them together. There you go, bingo. I'm putting together different sized groups. The only way to put together different sized groups is addition. So if you have a bunch of things that you want to put together, in this case, it has to be the same kinds of things. And so when he said how many pounds, the important part to me was that it was of the fruit. If I talk about the fruit, I'm talking about all those things together. Addition. Then give me the expression that I could write out in order to solve this.
2 1/2 plus 3/4 plus 1 1/4 plus 3 3/8.
And all the people freaked out. And this is really not fair. You say, Kate, this is so not fair. You haven't taught me to add fractions. True. And guess what? I'm not going to do. No time soon am I planning to add fractions. Is it because I think you guys can't add fractions? No. Is it because I'm not good at teaching adding fractions? No, I'm really good at it. That's actually how I got this job. I taught adding fractions in my job interview. But it's because if you had something like this on the GED, you know what you'd have?
A calculator.
You just have to know what to do. Your calculator will do it. So anybody who has a TI, pick it up. You should always bring this to class with you. Do you know how to type this in? Okay, first thing I see is a mixed number. Do you see that? So I have some good advice for you. First of all, when you're working with fractions in your TI, make sure that you're in math print mode. Math print mode will type like a mathematician does, and so it'll just be easier to look at, easier to make sure you're doing the right thing. So to do that, hit the mode button, arrow over the word math print, press enter to select, and then clear out of the screen. Now, the first thing I want to enter is a mixed number. To enter a mixed number, you need the U N over D button, which you're going to notice is in green above the N over D button. Anything in green, you should hit the second key in order to get that. So I'm going to hit second and then N over D. And now you should be able to arrow around and type in 2 1/2. Now, super important that you arrow right to get out of your fraction before going to type plus 3/4. Now, 3/4 is a regular plain old fraction, so all you need is the N over D button. So N over D and arrow in to put in 3/4. Okay, keep it up in that fashion. Arrow out of the fraction, plus the mixed number 1 1/4. And you guys type it in and I'll type it in, and then let's make sure our answers match. And humor me, guys, you type it in too. When I actually do this in class, I make every student hold up their calculator to show me. And then you can tell me why you hate your answer. What does your calculator say the answer is?
63/8.
63/8. Anybody pissed at their calculator for that answer?
No.
No, David's not even mad because he got scolded by me the other day for not liking improper fractions.
Yes, I did.
Well, David, here was one case where your third grade teacher was right. This is a case where I would not use an improper fraction. Does anybody want to guess why I wouldn't use this kind of a number in this word problem?
Oh, because what you're adding with.
There you go. They gave me a bunch of mixed numbers. They said, here's a bunch of mixed numbers. Because my original expression all had mixed numbers there, I would expect to have a mixed number answer. Now, some of you guys know how to do that by hand. Some of you guys don't, but you don't have to, because guess what? Your calculator will convert to a mixed number. Now, I honestly think it's easier to do by hand, but since I haven't taught you how to do fractions, unless you've been working on it in Odyssey-ware, you're going to need to rely on your calculator. And let's just get 63/8 back into your calculator. So hit the N over D button, type 63 on the top, and then 8 on the bottom, and then make sure you hit the right arrow to get out of the fraction. Now hit the green second button, and then times 10 to the N, and now hit enter. 7 7/8. If you stumble upon fractions, don't freak out. You just have to know what operation to do. Your calculator can handle the fraction. Okay, C. Bettina and 3 of her coworkers pooled their money to cover the costs of an office celebration. They each chipped in $35. And I ask, how much money do they have to spend on the party? Okay, guys, what's the proper operation here?
I'd say multiplication.
Yeah, multiplication.
Yeah, I definitely could use multiplication. Now,
Or you could add.
exactly. David pointed out I could also add. But I'm a mathematician. I'm super lazy. I want to go the fast way, so I'll put multiplication here. Then what would I be multiplying? What's my expression?
4 times.
3 times 35, right?
One of you said 4 times 35, and one of you said 3 times 35. Who's right?
Okay, the one that said 4 is right.
I love it, David. You're a humble guy. He's like, wait a second. What they notice that you didn't notice, David?
Is that Brit? Well, how do you even say that?
I don't know, Bettina. I just make up random names, and sometimes I Google things like Tibetan names so I can be multicultural. Okay, so what did I notice?
Yeah, I didn't notice her name. I mean, like I noticed her name, but I didn't count her as a person. So.
Poor Bettina. Yeah, exactly. Watch out for that. Watch out for hidden people, hidden numbers, and word problems. If I've got Bettina and 3 of her coworkers, I'm looking at chipping in 4 times. Okay, wonderful. So 4 times 35. So then my solution here would be what, 140?
I have a question. On the GED test, if you write it with the times, because I have a habit of doing 4 times 35,
Mm-hmm.
is that going to be wrong? Are they looking for the parentheses?
Great question. If they told you to write an expression on the GED, it would not be fill in the blank, it would be multiple choice.
Okay.
So it could be written either way in the multiple choice, and you would just have to recognize it as multiplication, even if that's not the way you usually write it. And as David and I talked about the other day, it could also be like this. So like there's more than one way to do this. Yeah. I mean, I could even do it like this. You might be like, what in the world? What a weird way to write this expression. Anybody want to try to chime in on what Kate was thinking this way?
Make it a little easier.
It makes it easier for David. Yeah, there's Bettina and 3 of her friends.
Yeah.
I got it.
So, you know, like the thing is I can't guarantee how they're going to write the expression. Now, all of us will get the same answer if we have good logic and reasoning. Yeah, so anyway.
I forgot that 4th friend, so I was thinking 3 friends and where the 3rd came from.
Yeah. Cool.
Thank you, David.
Anytime.
Well, and I mean, that's one of the reasons we're going to be doing this series. The GED has so many verbal tricks. So watch out for hidden numbers. Another thing to watch out for is just numbers spelled out. Sometimes if I just spell a number, you guys miss it altogether. Okay, let's look at Fatima. See? I'm multicultural, David. Fatima takes home $52,230 a year. I want to know how much she brings home each month.
Division.
Division, you say. What makes you say division?
The amount you have to separate it, group it into each
That's the total
month.
amount I'm going to make in a year, and I have to separate it. Now, how many groups am I going to separate it into?
Oh, months.
12. There's 12.
12 groups. I'm going to take this total and separate it into 12 groups. David, did you want to say multiplication?
No. I said months. I'm sorry.
Okay. Nope. That's cool. It's just a lot of people do multiply here, so I'll just speak to the internet, not David then. If you accidentally said multiplication and then you did that, like a lot of students just notice the same sized groups and do it backwards, which is fine. It doesn't hurt my heart. But if you did that, I would hope that you would look at your answer and go, oh, dear Lord, she makes $626,000 a month. I've done something wrong. Okay. Okay. So then my solution then would be what, guys? Use your GED calculator. You would have one if you were asked to find the solution.
4,352.50.
Wonderful. I'm so glad you said and 50 cents and not 0.5, because 0.5 is what came out of my calculator. How come you said 50 cents and not 5 cents, which is what I hear most often?
If it was 5 cents, there would be a 0 in the ones.
Yeah, absolutely. This is the tenths place. 5/10 of a dollar is like 5 dimes. I've got 50 cents, not 5 cents. Very nice. Thank you. Okay, so then E. In September, after dieting all year, Gregory announces that he has finally lost all 56 pounds he set out to lose and reached his goal weight of 185 pounds. How much did Gregory weigh before he went on his diet?
Addition.
Addition? But students tell me all the time, David, they say, no, Gregory lost weight. I better do subtraction. How come you said addition?
Because you want to know what he weighed before he lost that weight.
Exactly. I want to put that weight back on him. Oh, that'd be awful. But I'm trying to go back in time. I want to put that weight back on him. Yes, I'm going to need to add. Glorious. So then my solution?
He was 241 pounds.
Wonderful.
Wait, what was the answer that you just got?
241?
It's 185 plus
56.
Oh, I did 65. Go on.
You know what? I was writing worksheets today and making answers for them, and I was inverting numbers all over the place today. So I'm convinced that it's something to do with the barometric pressure, and it's not our fault, David.
I hope not.
Okay. But anyway, if the GED math teacher can make that many mistakes, certainly we're all capable of it. So that's a good advice to go back and check your work, right? Number 3, for each of the following scenarios, it says, determine the most appropriate operation to find the indicated information based on the given information. Then write an expression that could be used to find the indicated information. So I kind of stripped away the word problem this time, and I just told you what I've been given and what I'm trying to find. So let's take a look. A, it says I've been given that a TV is discounted $250 off, and the sales price of the TV is $849. I'd like you to find the original price of the TV.
So you're going to add it.
You want me to add again, and yet, David, again, most students would tell me subtraction here.
Yeah.
Someone in this group was thinking subtraction, don't feel bad.
But you want to know what the price was before they discounted it.
Bingo. If I'm looking for the price before the discount, I'm going to have to put that discount back on. It's back before it got taken off. And so it's definitely an addition problem. So the reason why I like to include problems like this, though, is that a lot of teachers teach what they call a keyword method for word problems. Did any of you guys ever learn a keyword method?
Yeah.
I don't like the keyword method because I can use keywords to fool students. Like I can use the word total in any kind of a problem, add, subtract, multiply, divide. And so that's why it's really important to know what your numbers are and what you're looking for. That's really the best way to solve word problems. Okay, so our addition expression would just be 849 plus 250. Notice they don't even ask me for the solution here. I'm good. Okay, so let's look at B. Apples cost $1.29 per pound. They're purchasing 5 pounds, and I want the total cost of the apples. David says multiplying. Ladies, do you agree with him?
Yeah.
Yes.
Yeah, beautiful. Then what would I be multiplying?
1.29 by 5.
By 5. Wonderful. So given here, Alfonso received 129,842 votes. His opponent received 107,804.
Subtraction.
Well, I don't know yet. It depends what the question is. I haven't read the find. How many more votes Alfonso had? Okay, I agree with you guys that it's subtraction. And yet there's this word more in here, which makes me feel like addition. Why is this a subtraction problem?
Because you're trying to figure out how many, like, the number that he has more than the other guy.
Yeah, Nicole slipped in there and said it's the difference. Yes, how many more, how much less? That's a measure of difference. It is a subtraction problem. Okay, so what would my subtraction expression be?
129,842 minus 107,804.
So now, guys, sometimes order matters, sometimes it doesn't. Like, for example, on this addition problem up here, it would not have mattered if I'd have gone 250 plus 849. So I want you to speak to you guys about this subtraction expression. If I did it the other way around, would it work?
No.
It would, but it'd be a negative, wouldn't it?
It'd give me the same answer, but it'd be a negative. So is it really the same answer if it's a negative? I wouldn't, how many more votes Alfonso have? A negative answer wouldn't make sense in this context. And so if you wrote it this way, I would not accept it in this context. Let's look at the next one. Oh man, did I cut this one off by accident?
I hope not.
To go on to the next page, I'm sorry. So it says, given the new playground will cost $25,000.
Well, that's it.
And each donor pledges $40. And then it says, find the number of donors needed. Division, absolutely. And so what would my division expression be?
It's going to be 40 divided by 2,550 or 25,000. I don't know what's wrong with me. It's been a long day.
Okay, that's what David just told me. 40 divided by 25,000. Do you guys agree?
I think I'm wrong.
You think you're wrong? Why do you think you're wrong, David?
Because you're going to come up with some weird decimal.
Yeah, how come I came up with some weird decimal?
Because you need to flip the numbers around.
Yeah, order matters when you divide. It's not about who's bigger and who's smaller. Some students think it is. But it's about the total coming first. So we had a total amount that we need to raise. The total amount we needed to raise was, how much was it, since it was on the other page, you guys?
$25,000.
$25,000. And we want to take that $25,000 and divide it into group sizes of 40. This guy pledges 40, this guy pledges 40, okay? And so the total comes first when you divide, and then you divide by the group information that you have. I'm glad we had that conversation because that's a super common student error. It's not because it gave me a weird decimal answer, because sometimes I will get weird decimal answers, okay? They happen on the GED all the time. time, but it is because I didn't start with the total. So now let's look at an algebra application. This won't take us long. You guys will find this easy now that we've had so much practice with this, okay? So it says for each of the following scenarios, write an expression that could be used to find the indicated information. So let's look at A. Jan has $11, Tim has 17, and Bobby has 5. Write an expression that could be used to find the total of the 3 friends' money. What do you guys think?
11 plus 17 plus 5.
Beautiful. So now look at B. This is how it'll be on the GED, and students will lose their mind. Jan has J dollars. Tim has T dollars. Bobby has B dollars. Write an expression that could be used to find the total of their money.
J plus T plus B.
Exactly. Thank you. Don't panic just because you don't know what it is. Whatever it is, we'd add it. And then you say, how much is J plus T plus B? I don't know, but if anybody ever tells me, I'll go ahead and add them. This happens a lot on the GED. So we've got to get comfortable writing expressions with unknown amounts. Okay, let's look at Marcus. Marcus plants 8 rows of carrots in his garden. Each row has 15 carrot plants. Write an expression that could be used to find the total number of carrot plants in the garden. I want you to find a total again.
8 times 15.
Yeah, how come you would multiply this time and not add?
Because there's 8 rows of carrots, but there's 15 in each one, so you want to
that same sized groups. Beautiful. Then let's look at Marcus, Mr. Unknown, Mysterious Marcus, okay? Marcus plants R rows of carrots in his garden. Each row has P carrot plants. Write an expression that could be used to find the total number of carrot plants in the garden.
R times P.
R times P. Now, who is with us? Who remembers? When I want to multiply together a letter, 2 letters, how do I do it?
With a little dot, the colon.
I don't even need a little dot. Now, would I be wrong if I wrote it this way? No, I wouldn't be wrong.
Or
But
the
there's an even
parentheses.
simpler way. What's the even simpler way?
Or you can just smush them together.
Yeah, David's like, smush them together.
Yeah.
Proximity means multiplication. Tanya is 15 years older than her brother Berto. Berto is 12 years old. Write an expression that could be used to find Tanya's age. Tanya is 15 years older than her brother, and I want to find Tanya's age. I think if I subtract, I'm going to get someone younger. So what should I do instead?
You should add.
We should add in this case. Now, there's one on the homework where it's just like that, Ashley. It's presented backwards, and even though I say someone is older, I actually ask you to find the age of the younger one. So really good to pay attention to which one are they asking me to find.
Yeah,
So since, oh, you were thinking like it said, what is the difference between their ages?
yeah.
Cool. Okay. Yeah, but this time I said write an expression to find Tanya's age.
Yes, you did.
Yeah, and I love that we're having this conversation. Ashley's like, I don't like it because I feel silly. But I like it, Ashley, because so many students struggle with this. They just look at the information and assume they know what I want them to find. So they don't pay attention to what I ask them to find. You know that there's a meme on the internet, right, that says, like, if purple aliens wear hats, how many pancakes are on the roof? Or it's a joke about why word problems don't make sense.
Yeah.
But I can do that to my students. I could information dump all these numbers to them, and I could say something like, how many hours are in a day after all that? And they're so busy mushing around the information, they didn't even notice that I asked them nothing about the information.
I'm that guy.
You're that guy. Don't feel bad, but what you should do is you should get in the practice of going and looking at what you've been asked to find. So it says, write an expression that is used to find Tanya's age. Make a little note to yourself. I'm supposed to be finding Tanya's age, and we're going to be looking at that in a future video. Okay, let's look then if we had instead of numbers we had variables. Tanya is Y years older than her brother Berto. Berto is B years old. Write an expression that could be used to find Tanya's age. So once again, we want to find Tanya's age, and what we know is Berto's age, and we know how many years older she is. We know the difference in their age. What should I do?
Y plus B.
Yes. And I'm going to do B plus Y, but it's not wrong the other way around.
Mentally, Kate, why would you do B plus Y?
Because when I think of someone being a few years older, I usually start with the age. Like if I'd even been thinking about it, I would have written this one 12 plus 15, but I listened to somebody else's. I usually start with the age and then put on the change. And that's why I don't make an issue with subtraction. When you're 5 years younger, you've got to start with the age and then subtract the 5.
Okay.
So I get in the habit of always starting with the age and then doing the change afterwards so that my students can get in that habit and not make issues when order does matter. Because it doesn't matter with addition, so we think it never matters. But if I were taking away, it would matter.
I would also do B plus Y, but I didn't know why I would do that.
That was the mental thought process for me. So good question. Let's look at G then. The deli took inventory yesterday and found that they had 22.5 pounds of tavern ham in stock. Over the course of the 2 days since then, they have sold 17.75 pounds. Write an expression to represent the amount of ham they still have in stock.
22.5 subtracted by 17.75.
Absolutely. And I couldn't switch the order in this. I would need it in this order. It would matter with subtraction, right? Because I can't have negative amounts of ham.
No.
It's just not going to work out for me. Okay, H. The deli took inventory yesterday and found that they had T pounds of tavern ham in stock. Over the course of the 2 days since then, they have sold S pounds. Write an expression to represent the amount of ham they still have in stock. T minus S. And absolutely, I would stress again, can I write S minus T?
No.
No. We're going to need to start with the total and then remove a piece. Let's just quickly finish up these 4 and then call it a class. The Colinda Theater seats 2,700 guests. Each row has 75 seats. An expression to represent the number of rows in the theater.
2,700 divided by 75.
Brilliant. Why did you choose divide?
Because you're wanting to know how many rows. So you're dividing seats by people.
Wow, I've got the total and I'm breaking it into these same sized rows in this case. Wonderful. Okay, so then the Colinda Theater seats G guests. Each row has S seats. Write an expression to represent the number of rows in the theater.
G divided by S.
Yeah, I need to start with the total. There's G guests total in the theater. And then I need to divide by the size of a group in this case, the group information. Okay, so order would matter. Now you could write it like this, or you could write it like a mathematician, G over S. It means the same thing. Is anybody mad at me?
No, but K is subtraction.
K is subtraction. Dottie is 23 years old. Her mother is 59 years old. Write an expression that could be used to find the difference in their ages. Okay, awesome. You're right, Ashley. K is subtraction. How come it's subtraction here with the ages when it wasn't before?
Well, it's the difference in their ages, the difference in the absolute number subtracted.
Which one would you write first?
Good question, David. It matters. Which one would I write first, you guys?
The bigger number.
I'd have to write 59 first. Now, some of you guys looked in the last video you saw, or I could do it in the other order, I suppose, and then put it in absolute value bars. But that's not the way most students would think of it. So if you never would think of that in a million years, this is how we usually do it. We just make sure the older person comes first. So last one then. Dottie is D years old. Her mother is M years old. Write an expression that could be used to find the difference in their ages.
M minus D.
M minus D. How come you started with M?
The mother would obviously be older.
The mother would obviously be older. She's the mother. If she's younger, I don't know what kind of weird world we're living in. Yes, it's fair to make that assumption. Now, if we didn't know that she was the mother, then you would have to have, like, you know, Dottie is D years old, Tanya is M years old, then you would have to use those absolute value bars. But since we know she's the mother and she's older, we'll be fine. Thank you guys so much for coming to virtual GED class. We are going to next week be carrying these word problems even further, looking more at interpreting word problems. Join us then.